if you do have questions, just pop them in the chat. I should be able to see them as they come up. So starting off then, so this starts a question. So we're going to sketch a graph of y equals the modulus of x plus 2. So remember what we do. Firstly, if we just do a little sketch of what y equals x plus 2 looks like to begin with. Yeah, again, apologies if the sound's a bit sensitive and you hear the pen quite loudly through this today. So let's just that. Okay, so it's going to have a y-intercept of 2 and it's going to cross there at -2. So when we find the modulus of this, we're just simply going to flip the negative parts in the x-axis and we should get something that looks like this. So that's just kind of a reminder what we did yesterday. Then what we've got to do is hence solve the equation, the modulus of x plus 2 equals 3. So what I'm going to do is I'm going to draw the line y equals 3. Okay, so this is the line y equals 3. And we can see that there's actually two solutions here. Now, the first solution, very simply, and I know you probably can see this just from looking at the equation itself, but the first solution just comes from simply just treating it as x plus 2 equals 3. Okay, for this solution here, which I've highlighted in green, this is the one that's not changed from how it was before. Okay, so it simply is, where does the line x plus 2 and 3 cross? Well, that's just going to occur when x is 1. This other solution, though, it's the one that I'm highlighting in yellow. This is the one that has been reflected. Okay, so the one in green hasn't been reflected. The one in yellow has been. So in terms of if we want to think of how we'd solve this equation, yet again, I know that this is quite a simple one you probably can do in your heads, but it's going to help for the more harder questions, this method. What I want to do is think about this line here. Okay, I'm going to shade it all in blue there. Okay, so all of this has been reflected in the x-axis. So if we think back to transformations, if we reflect something in the x-axis, we multiply it all through by -1. So what I'm essentially solving is minus x plus 2 equals 3. So this becomes minus x minus 2 equals 3, which then leads us to x being -5 as the other solution. You can check that because -5 plus 2 is -3. If we take the modulus of that, we take the positive answer from that. So this leads us on to how we solve modulus equations, which is going to be our aim for today. So if we're solving equations in the form modulus of ax plus b equals c, or even if this is cx plus d on the end here, or this is just like an x in here, then what we need to do is we need to solve this firstly as if the modulus wasn't there, and then we'd solve it as if we were timesing this through by -1, but just the left-hand side of this, okay? Because basically what happened with these straight line graphs, when you do the modulus, at that root, you're then going to reflect it in that x-axis. And remember, when we reflect it, we essentially times the whole equation by -1. Okay, sketches will help here. It will help see how many solutions you've got, where they are, and also kind of which one's the reflected one, which one's not. So just check questions for chat at this point. No. So firstly, we're going to solve the equation modulus of 2x minus 3 equals x plus 1. So what I'm going to firstly do here is I'm going to sketch the modulus of 2x minus 3. So I'm going to sketch that left-hand side, and then I'm going to sketch what that right-hand side would be. So firstly, if I'm just going to do a graph of y equals 2x minus 3, just to check what that looks like first. So if I draw that graph, I'd have a y-intercept of -3 and a root of 3/2. Okay, so that's just y equals 2x minus 3. So when I draw the modulus, it's going to look like this. Okay, so I've still got that root of 3 over 2. Okay, 3 over 2 and greater, that graph looks the same as 2x minus 3. Okay, because when x is greater than or equal to 3 over 2, it's 0 or greater. But when x is less than 3 over 2, then it's going to be negative. But of course, because it's modulus, we're going to take the positive version of that. So that's the part that gets reflected. Then what I do is sketch a graph of x plus 1 on here as well. So that's just going to have a root of minus 1, okay, because obviously when you put in x as minus 1, it's going to give you y as 0, and you have a y-intercept of 1. So you can see here we've got two solutions. The one in green is the one that's just as normal, okay, so it's as if the modulus wasn't even there. The one in yellow is our reflected solution, so that's where I'm going to need to times that 2x minus 3 by negative 1. So to find my first solution, the one in green, I simply just solve it as if the modulus wasn't even there. So when I do so, I'm just going to get, sorry, no, that's a mistake. So I just solve that and I get x equals 4 when I do so. So that's the one in green. Now I'm going to find the one in yellow. So the one in yellow, I need to multiply that 2x minus 3 by negative 1. Remember, you need to multiply the whole of that by negative 1. So don't just times the 2x by negative 1. Make sure the whole thing gets multiplied by negative 1, hence why we've got the bracket. So I'm going to multiply that bracket out. Do a little bit of rearranging. I'm going to solve it. I get x equals 2/3. Okay, so that's my reflected solution that I've got there. Say if you do have any questions, let me know. I say the sketch is always important because it won't always be the case of one solution is reflected, the other's not. It depends on what graph that you've got in this, for the particular question. So you could potentially have a situation where maybe you only had one solution, it's the non-reflective one anyway. Maybe you only have one solution that is the reflective one. It depends on what the equation of the line is. Okay, so in this case, we did have two solutions, but it's always important that we do the sketch just to double check. So if you've got any questions, please let me know in the chat. We'll just do a quick check now. Right, on to example 7 then. So now we're going to do this with some inequalities, and this is definitely where you need to do the sketches. I mean, okay, you needed to do the sketches before, but you definitely need to do it here. So next one, we've got modulus of x plus 3 is less than or equal to 4. So, of course, I'm going to do my sketch first. As you get used to drawing these modulus graphs, you'll probably just be able to kind of draw it in one go, but if you still need to draw x plus 3 first and then do your reflections, that's absolutely fine. And then on the right-hand side of this inequality, we've got 4. So I'm just going to draw a straight line that goes through y equals 4. I can see I've got two solutions to where they meet. So this is where it'd be equal. Okay, but I'm looking for where this is less than or equal to 4. So I'll come back to that in a second. But the first thing I'm going to do is I'm going to find my critical values. So if you remember from inequalities, your critical values are where instead of having a less than or equal to sign, just imagine you've got an equal to sign. Okay, it's where the modulus of x plus 3 is equal to 4. So firstly, finding that green solution, I just do it without the modulus, so just take it away and you've got x equals 1, okay, because that hasn't been reflected. And then this yellow solution, this has been reflected. So we do minus x plus 3 equals 4. And then when we solve that, we end up with x equals -7. So your critical values are x equals 1 and x equals -7. So because we're looking at where the modulus of x plus 3 is less than or equal to 4, what I'm looking at is everything that is under 4. Okay, it's less than or equal to 4, so I need to look at everything that's under that 4. So from my sketch, I can see that it's between -7 and 1. I'm putting less than or equal to signs because I've got less than or equal to in the question. Let's have a look at another example now. So I've got modulus of 2x minus 1 is greater than 9. Draw a sketch. So your root of 2x minus 1, that would be a half, and it would cross through at -1 originally. But what would happen is you'd reflect it. So it's now going to cross through at +1 instead. Okay, so the root's at half. Originally, it was crossing through at -1. That was your y-intercept, but now it is crossing through at +1 because you took the modulus of it. This doesn't have to be to scale, remember, it's just a little sketch to see what is actually happening with this equation. How many solutions we've got, where are they? So I've got 2 solutions here. Obviously, you don't have to do all this kind of highlighting business that I'm doing, just hopefully that's making it a little bit easier to understand in terms of which is reflected, which is non-reflected. So firstly, find that green one. This is your non-reflected one. This is just where x is 5. And then we want to solve the other side of this. So we just do negative or minus 2x minus 1. And when we do that, a bit of solving, so we do minus 2x plus 1 equals 9. And we get x equals -4. So in this question, we're looking at where modulus of 2x minus 1 is greater than 9. So that's everywhere where it's above 9. I haven't really drawn much of this graph that's actually above the 9. But I hope you can see there, it's wherever x is less than -4 or x is greater than 5. Okay, if you put in a value, and you can check that with just some simple numbers, can't you? Put in a value of that's bigger than 5, let's say 10. 2 times 10 minus 1, well, that's definitely greater than 9, isn't it? Put in something like x as -10, or 2 times -10 minus 1 is -21. The modulus of -21, though, is greater than 9, so that works as well. Or you could put in something that you know shouldn't work, such as 0. When you put in 0, you get the modulus of -1, which is 1. 1 is not greater than 9, so 1 doesn't work. The final example then for today is this example 8. Solve the equation modulus of 5x minus 1 is greater than 3x, and we're going to give our answer in set notation. So a little bit of a reminder of what that looks like if you're not sure. So as always, draw a sketch. Be very careful with the sketch of this one because it can be easy to get this one wrong. Now 3x, I'm just going to draw going through the origin like that, okay, because 3x, it doesn't, well, the intercept is 0, 0, so that's also the root as well. Then when you do your 5x minus 1, now just be careful when you do the sketch, 5x minus 1, the gradient is greater than 3x, okay, the gradient of 5x minus 1 is going to be 5, so just bear that in mind when you're doing the sketch. It's going to have a root of a fifth, so this is my root here of a fifth. So I'm going to draw it steeper than the 3x graph. Okay, so I've got my 2 solutions here and here. I can see that one hasn't been reflected and one has been reflected. So find your critical values. So solve 5x minus 1 equals 3x, and we just get x equals a half when we do so. And then we're going to solve 1 minus 5x equals 3x, okay, just times that. Well, I'll put that extra step in. Okay, just times that left-hand side by -1 because you've reflected that 5x minus 1. And when we solve that, we should just get x equals an eighth. Because you're looking at where the modulus of 5x minus 1 is greater than 3x, you just basically want to look at where is this above the line, okay? So if you look at your modulus of 5x minus 1, okay, it's that like V-shape graph that we're looking at, remember? All this bit, all these parts here are above the line of 3x, okay? Because you're looking at greater than. So we put in set notation, we need these curly brackets. And what we're having here is, firstly, we've got this solution in yellow is your 1/8, and this solution in green is your half. So if x is less than an eighth, okay, it's solution, or, okay, we need the or sign here. If x is greater than a half, it's also a solution. So sometimes I might just want set notation. The reason why we use set notation should actually become a little bit more apparent in the next couple of weeks when we do a bit more work with like range and domain and things like that in the next few lessons. So just a little reminder of what it looks like when we put in set notation there. Right, that's all the examples today, but before we go, I want to do a quick review and get you to have a go at a few questions yourself, just so you're all kind of nice and prepared for the questions that you've got. These ones will be slightly shorter than some of the ones that you've got behind in questions, but just kind of a good way to practice. So the key thing here from today is that if we're solving equations in this form, modulus of ax plus b equals c, we want to solve it without the modulus first, and then we solve it when we times it through by -1. But some equations will be different. It won't always just be equals c on that right hand side. So that's why it's always important to do that sketch first, so you can see how many solutions there are and where they are as well. Especially it helps with the inequality graphs, so you can see where it's above, below, or in between, etc. So I've just got a few questions here for you to have a go at. So just the ones that I've highlighted in yellow, have a go at these questions and just kind of to check with me that you know what you're doing, you understood what we're doing. So have a go at these, and then I'll pop up the answers about 5 minutes time. So give me 5 minutes to work through these, and then we'll pop up some answers at the end. But if you do have questions, just ask as you go along. So see if you can do it first, because they might be a little bit different than some of the hand-in questions, so they're good ones to practice. So I know there might not be ones in the booklet, but I think they're good ones to practice, because they might be a bit different. There's a few exponential ones in there. And hopefully the microphone hasn't been too bad today. So a couple more minutes, or let me know if you need a little bit longer. Right, we'll go for the answers in about a minute's time, but do let me know if you need a little bit longer. Okay, I was going to put my form thing up there again, but it doesn't seem to be working today. A lot of things don't seem to be working today. So I'm just going to pop up the answers then. So they've done it a slightly different way. What we've done, they've kind of just done it all in a couple of lines. And I know they haven't done sketches here for these solutions, but hopefully you can see the answers. So we should have x is between 18 and 22, but there should be less than signs then. For that part A, then between 3 and 9 for part D, and then for H we get between, so we just solve it for the 2 to the power of x, and you should get between 4 and 32, but then just, I mean, you might be able to do it just trial and error, but you could also use logs, of course. So if you're thinking what's 2 to the power of x equals 32, what would x be? Well, we could always do log to base 2 of 32, of course, which would be 5. So let me know if you've got any questions. If not, that'll be it for today. Just when you go through the handing questions, I believe it's one of the first ones. I think there's a little bit of with the formatting of it. I think it says like f equals x, and then there's like some modulus, something like that after it. I believe it should just be f of x equals modulus of 5x, something like that, or the modulus of f of x. So just where it says f equals x, it should just be f of x. Okay. So 3 questions today for handing questions. Yesterday make sure you've done all 4 questions because it was on 2 pages. I think some people did the first page, but not the second one. Right, we'll leave it there then today. I'll see you on Thursday for range and domain, which will be a really important one.